Contra Corporation is a technology based company that offers IT services and digital solutions to its clients. Because of the nature of its work, the company depends heavily on a stable and efficient network. Contra Corporation also operates three branches: the main branch, the east branch, and the west branch. All of these offices use computers, servers, and different workspaces that support their daily operations. One of the most important requirements is the communication between the offices. Since the branches are located in different areas, they need a fast and reliable WAN connection. A strong one ensures that all three branches can exchange data without delays. Another requirement is the automatic IP addressing. Using the DHCP makes it easier for the network to assign IP addresses to every device in each branch. This avoids manual configuration, reduces errors, and help organize all connected devices more efficiently. For network traffic to flow smoothly between the branches, the company should also use a dynamic routing protocol, especially that EIGRP. To keep the system organized, each branch should have its own subnet. Subnetting divides the network into smaller and manageable parts. And lastly, the network must be regularly tested and monitored. By checking performance, connectivity, and possible issues, the company can prevent downtime and immediate fix any problems. These networking requirements are designed to help contract corporation maintain a secure, efficient, and scalable network that supports its day-to-day operation and future growth.
So for the physical view of our network design, here with the city topology, this is the intercity. Start to take a look at the branches. We have Quinta West Branch, Quinta Main Branch, and Quinta East Branch. For the West Branch, take a look. We have each router, server, PCs, laptop, and printer. For the main branch, we also have each routers, servers, PCs, laptops, and printer. For the East branch, we also have a router, switch, server, PCs, laptop, and also a computer. And for the first router, in the main branch, it has an IP address of 10.0.3.1/24. For the West branch, it has an IP address of 10.0.4.1/24. Lastly, for the East branch, has an IP address of 10.0.1/24. So we use 24 because it makes the network easier to manage and keeps the addressing scheme organized across branches. For the DHCP, every branch router has its own DHCP pool. The main branch uses MB pool, the east branch uses EV pool, and the west branch uses WV pool. So we choose this setup because the HCP traffic stays within the branch. This reduces one usage, and even if the link to the main branch goes down, each site can still assign IP addresses locally. It's simple, reliable, and fits our network structure. Well, for the routing, we use EIGRP because it is suitable for our network since it supports VLSN, adapts quickly when links fail, uses low bandwidth, and easy to configure. This ensures stable communication between all branches. Lastly, for the security, we configured enable secret or encrypted privileged access. Then the service password encryption for all plain text passwords, and the user accounts for authenticated access.
The router's name contra main branch so administrator can quickly identify it in the network. The enable command is used to enter privilege exit mode, where advanced configuration and system control are performed. An enable secret password is set and encrypted using service password encryption to protect access to secure configuration mode. By using show running config to display all active settings on the router, such as interface password, DHCP, and routing configuration. The IP DHCP included excluded address command, reserved IP range 10.0.4.1 to 10.0.4.20 and 10.0.31 3.1 to 10.0.3.20 to prevent DHCP from giving these addresses to client, keeping them available for servers, routers, and other static devices. The DHCP pool MB pools provided automatic IP assignment to device in the 10.0.3.0 networking, ensuring efficient client addressing. The default router 10.0.3.1 inside the pool set the gateway so all DHCP client can reach other network and branches location. The configuration secure router access automate IP management and ensure smooth communication between all.
So guys, dito ipapakita ko kung paano namin kinonfig east tsaka west ng branch ng router. So, ang first step na ginawa namin is naglagay kami ng hostname. So, para madali sila makilala. At ang second step naman is naglagay kami ng password for security. At ang pinakamahalagang ginawa namin dito ang DHCP. So, mamaya papakita ko kung ano yung DHCP. So, punta muna tayo dito sa CLI. Ayan. Ito, type muna natin ang password. Mali. So, yan. Type enable. So, password ulit. So, show running config. So, ayan. Ito ang DHCP, guys. So, bakit? Bakit kami gumamit ng DHCP? So, nag-set kami ng DHCP para sa, sa mga, nag-set kami ng DHCP para mag-set ng mga address sa mga, may mga fixed na IP. Sa mga device na may fixed na IP. So, nag-set din kami ng DHCP pool para sa mga, automatically na makakuha ng IP at gateways at DNS ang mga laptop at PC. So, ang DHCP is gumagana siya para mapabilis at mapaayos ang pagmamanage ng network sa mga branches. So,
Hello everyone, I'm Reiann to explain to you how to deal with broken routers, disconnected links, or how you can verify whether a router you want to check is truly connected or not. So for this case, as you can see on the router on here on the east branch, it indicates these red markers. This means that it is disabled. To check that further, you can access the router here on the main branch and access the CLI, inputting this code right here, show IP route, in which displays the complete number of subnets. However, since the east branch router is disabled, instead of getting the supposed complete number of 8 subnets, you only get 5 subnets. This truly indicates that the router on the east branch is disabled. So how can you repair that? First, you can power on the router again, then access the CLI. So I already had pre-coded the necessary information ranging from the hostname up to the necessary like IP addresses so that it can properly establish a link onto the networks you wanted to connect onto. So before we can proceed, I want to explain another code snippet that you can use so that you can further verify whether the network you want to check is truly connected or not. So let's access the router right here, the main branch router. Open the CLI. Okay. Okay. Input the necessary passwords needed. Okay. Enable. Okay. So the previous one was show IP route. Sorry. So this displays the complete number of subnets, which is 8, since we do not have any broken links, any disabled routers. So the other one is show IGRB neighbors. So what do these values mean? These values are the values for your routers right here, for the east and the west branch. Okay? So if one of these do go missing, it means that the router or the link connected to them are broken or has been disconnected. So we can tackle these other code snippets that we can use for checking for our network. So we can access one of these devices, for example, this one. Go to desktop, then go to command prompt. So let's go type in ipconfig /all. So this displays the overall device name and the attribute it got. So the IP addresses and etc. For example, I want to input another one. So I want to release or to delete the IP address right here. This one. So we can input IP content, yes, then release. What this does is it fully resets the IP address, the subnet mask, the default gateway, and the DNS server. So what if we want to request new ones? So by type in ipconfig slash root and wait for a little while, your device receives your new IP address, your new subnet mask, your new default gateway, and the DNS server.
So now we are going to verify the EIGRP neighbors and their relationship. To do that, we should just type show IP EIGRP neighbors. Neighbors. And then it will then process it and it will show it to the terminal, like here. For failover testing, as you can see, I have removed the serial port here. So let's show IP neighbor, EIGRP neighbor. As you can see, it does not return anything because it is not connected. So let's try to connect it. And then show EIGRP again, neighbors. Now it is connected as you can see here. So now let's test the ping or traffic loads. So let's just ping the corresponding IP. Let's wait and see. And then there's the result. And then for now, let's also check the network latency. To do that, let's call tracer, then the ping, then the IP, I mean. And then there you go. It also shows it. Let's try and see now if the simulation works. So it works. Now for the main branch. Okay, works. And then sending packets. Okay, pretty much works.